Well, a staircase like this looks very pretty, but of course it needs to fulfill a structural function, and quite a significant one, because there would be quite a lot of traffic going up and down. And as we all can see, there's no support. So it appears to be cantilevered or free floating. Of course, there are some brackets there, and what this staircase does is to combine the functional with the decorative. And there's some very interesting features on this. First of all, it's very nice mahogany throughout. And inside of this are actually 4 very large beams actually holding this up. And that gives it actually its structural strength over the length. Also, the whole thing works as one package, I would like to call it. So everything interlinks. So everything is touching each other and supports its own weight and the load that will be on it. For example, these balusters are dovetailed in here, so they have a tapered joint that slides in sideways, which holds up and down really well. But as you can see, some of these are actually loose in this direction, but the tension in this way is actually well supported. And that actually holds this very heavy handrail, which again looks like a large solid piece of mahogany. It is solid wood, but it's made out of composite parts. Because as you can see on the scroll, it's highly complex. To actually make that out of one lump would be almost impossible. So what they do, they take all these sections and form them and put them together and then actually shape them as one whole. Another interesting feature here is this very pretty curve, or this double curve underneath, which is, as you can hear, it's very, very thin. So again, it's, I would say, about 5 or 6 mil thick mahogany that's jointed in 2 spots, and then it's shaped with a plane to form, to make this wave, and that's then applied to the outside. Again, it's all about camouflaging the pine beams that are actually inside holding it up. The same with these beautiful carved brackets, and they really give the tread an end, and it's traditionally done on most staircases. So this would have been built in a workshop, most likely, or at least laid out very, very accurately to get that right, because you have only a certain amount of distance and a certain amount of height, and that has to be divided among all those treads in exactly the same height. So there's quite a bit of calculating and laying out to do to get that right. And again, having very, very precious material, it would have been really important to get that right in one go. Traditionally, you see that on most staircases, it's just nailed in from underneath. So there's just 2 little nails going into the bottom of the handrail, and that's pretty much it. Because all the tension would have been downwards or outwards. And then for the outwards tension, the dovetail would do that, and downwards is pretty much gravity. And therefore there's no need to have a proper joint on the top. It's very likely that the architect made a top elevation of it to get that scroll perfect. Again, it's mathematics will actually make that on paper. You can draw it quite easy, or not quite easily, but you can calculate that to have it right. But then to actually make it would be quite tricky, because you of course have to work in 3 dimensions. So the rise of it, or in this case the drop of it, and then the shape of the scroll, and then the molding on top of it. So there's actually 3 factors or variances you have to actually keep in mind. So it would be very tricky. So they would have used scrapers to make that, and of course some molding planes. And of course the center would have been carved as well, where you can't get into with any planes. They would have cladded a core of a more inferior, or you could say a cheaper timber, and therefore it is very likely that maybe the inner section could be actually a solid piece, which they carved out, but then as soon as the scroll gets bigger, at some point you just have to, you can't go any further. And I'm sure if we look a bit more in detail there, you can see the joints. But again, it was so well made that even after all this time, the joints are still very, very tight.